Welcome. Let's take a look at graphing sine and cosine functions. And I first want to start off with the idea of using different number line. We are used to using this number line, the basic integers. The next two are the same number line, but just set up a little differently so it matches trigonometric functions better. In the first one, we use integers. In the next one, I'm basing it on pi, but I'm not writing pi. I'm using the approximate numbers. So, for instance, this here is 3.14, which would be the same as pi, which I then put under there. And if I went up, put it on the first one, it would be about here. And then, of course, this one here is half of that. So 1/2, that's about 1.5707, as you'll see below on this paper. And that's pi over 2, and it would be placed about here if we were to do that. So I could have gone and used this top one and done pi over 2 and pi, and so on, because we would have 3 pi over 2 here and 2 pi here. It just gets a little messy. So therefore, this is going to be the main one that we will use in the things that you'll be doing for, graphing sine and cosine and the other trigonometric functions. Now, you can do all of the graphing on a TI calculator or other calculators, but here are some things if you do it on the graphing calculator that's a TI. And actually, the first thing is true for any calculator. Your mode has to be in radians. You're only going to use that for graphing trig functions, and you have to remember to go back to degrees when you're not graphing. So there's a mode button on the calculator right at the top. Just press mode, move down, move over, choose radians, press enter, and you'll be set. But you'll have to make sure you change it back later, or else you get some weird answers on other types of problems. And this is the window that I will recommend for using a graphing calculator. And I used to use pi over 2 for the scale for x's, but I think using pi, oops, that's not supposed to be a 2 there. So it's supposed to be pi over 4 here. And pi over 4 is a little bit better for graphing some things. There are a couple of problems where it'll be better to do with pi over 6. Fix that sometimes. So pi over 6 or pi over 4, and these are the actual approximate decimal numbers for those. If you put them in as pi over 4, pi over 2, or pi over 6, then you will end up with a much, it'll be more precise, but this is good enough. Notice that I have the x's going from -1 to 7. So I back up from here, we would be going -1 to 7, which means we'd be going from just before, or from about negative pi over 2, all the way over to past 2 over pi, or 2 pi rather. So that means mainly that we'll get 0 to 2 pi for anything that we graph, and a little before and a little bit after. Right. Now, that's the way on there. And the maximum minimum for the y's is going to go from -4 to 4, and you'll see that on a graph in a moment. We'll be doing a number of transformations, and let's start with that because we have to do that for each of the things. Back to here, if we look at the first problem, you'll see we're going to graph in this type of system where we'll go from 4 to -4 for the y's, from -pi to 4 pi for the x's. And we're going to be looking for these things: amplitude, vertical shift, period, phase shift. For those things, we use the placement on the equation. The main parent function for these is y equals sine of x. But we're going to essentially complicate it by moving it around from that. The basic y equals sine x looks sort of like this. These other things will do everything else with it. They'll move it sideways, they'll move it up and down, they'll extend it, or I guess you say go farther up, farther down, or less, squish it in or pull it out. And so we're going to look at each of these. First thing, That number in front of sine x, if there was a number here in front of sine x, you would take the absolute value of that, and that will give you what's called the amplitude. And the amplitude is, instead of a normal one, it's how much higher up or lower that it goes, like that. So, and actually, if there's a center line, it would be this distance or that distance, which is still normal for the basic one. That's called the amplitude. We use the letter B to determine the period. Use B to determine the period, which is one cycle. And you're going to most of the time graph two cycles of the function because it repeats itself. They always constantly repeat themselves. So there's a little equation that the period is equal to 2 pi over b. So we need to know what b is and divide that into 2 pi in order to get what one cycle would be. And then we're going to use C. Use C with the B to get the phase shift. Phase shift. And we're using a little equation of C over B. And then the last thing is this D, and what that does is this gives us the vertical shifts. Now, C and D do opposite things for us here. The vertical shift is how far up and down. The C over the B will tell us how far to go over one way or the other. So let's mark these. Amplitude, the period, the phase shift, and the vertical shift. And those four things we will find. Here, next, they're sort of out of order, but we can still use them. So I'm going to write this, remembering that A is supposed to be here. This is supposed to be bx minus c, and then right after it is supposed to be d. Well, the first thing's really easy because you know there'd be a 1 in there, so the amplitude will be 1. And if there was a number in there, then we'd know that. At the end of it, there is nothing at all, so that's the same as like plus 0. And so I'm going to write plus 0, which means the vertical shift is 0. And then for the other two, if you have bx minus c, and that means that it's 1x minus 0 because there's nothing in front of the x, so the b is 1. And we're not adding or subtracting anything to the x, so that means that the c is 0. And that means the phase shift, so, actually, then let's do the period. That was 2 pi over b, which is 1, which means the period is 2 pi. The phase shift is c over b, and the c is 0 and the b is 1, which is equal to 0. And therefore, we can say the phase shift is 0. So now, in order to graph it, we'll use part of that information, but the most important part is the period. If it's going to go to 2 pi, that means we're going to graph from 0 to 2 pi here. And we're going to use this table down here to help us. I'm taking 2 pi and I'm going to split it in half and then the halves again to help me get the points where we can graph this. And the way we would figure this out is we would take the sine of 0, because we're going to use this equation. In fact, I'll just write it as the y value. So in fact, down here, the x value is going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Why am I using these? Because back up here, I want to find out for 0 where I'm going to go to up here or down here. For pi over 2, where to go here and here, and pi. So I want to know where to graph it on each of those spots. Now, I need to erase all those so I can put the real info in a moment. Let's erase all of that, and we'll find where this actually really is graphed. So we're going to use down here, y is equal to the sine of x. 0 is that x. Y is equal to the sine of 0. You use your unit circle knowledge to know that the sine at 0 is 0. And then for pi over 2, we're going to do y equals the sine of pi over 2. Well, the sine at pi over 2 on the unit circle is the number 1. Okay. So we'll put a 1 here. Y equals the sine of x. Oops, and actually now I'll just replace x. Sine of pi. And when you're at pi, around the unit circle, that's just as a quick reminder. So over to here is where pi is. And at that point, the x value is -1 and the y value is 0. So the sine, though, this is cosine and this is sine, so the sine is 0, y equals 0. For 3 pi over 2, y equals the sine of 3 pi over 2. And again, on the unit circle, that's down here. And the cosine is 0, and the sine is a -1. So y equals -1. And then for 2 pi, we're right back at the beginning, which is the same as this. Now we're going to graph those 5 points. 0, 0 is our first point. Pi over 2 and 1 is the next point. So at pi over 2 here, we're going to go up to 1. And then for pi, we're at 0, and 3 pi over 2, we're at -1. And then at 2 pi, we're at 0. So we curve around these. And that is y equals sine x. 2 periods. So we repeat it. Since this one is the same as that one, that's the first one there. So we go to where the next one will be, and we basically just repeat at each of those equivalent points. And of course, put zeros on the ends because they're going to go continuing add those curves there. And we've done one cycle here and another cycle here, or one period and another period. And we did it by figuring out the points this way. If you did this on a graphing calculator and use the table value, you would end up with the decimal points here, negative, was it 7.505, I think it is, for pi over 2. No, 1.57. Got my number off on that because it's half of 3.14, which is 1.5707. And then we would, triple it for 3 pi over 2 here. So you get the decimals on the table, but you'll need to do this if I were to say, give me the exact number for those, for the exact one. Anyway, you now have this this graph. This is the basic parent function of all of them, the sine x. But in a way, there's 3 different parent functions. There's also one for cosine x, which would be over here. Before we do that, let's look at the changes of differences if we do 3 sine x. So the change in here is going to be the amplitude. Okay, so the number in front is the amplitude, absolute value of A, so it's absolute value of 3, so it's a 3. The vertical shift, we need simply whatever is here, and there's nothing there, so it's 0. For the period, dx minus c. So that means we need b, which since there's nothing in front of it, that means it's 1. So for the period, it's 2 pi over 1, which again means it's 2 pi. And the phase shift, there's nothing here, so we're subtracting 0, so that means we have 0. Okay. That means we don't change a whole lot here. We recognize that the amplitude means that instead of it going like this, it's going to go up more and down more. So let's take a look though at graphing them here. And our main function is y equals 3 sine x. So y equals 3 sine of 0. And the sine of 0 is 0. So that means that y is equal to 0. So when our x is 0, our y is 0. Now, I'm going to put pi over 2, pi, 3 pi over 2, since I know those are going in there. Anyway, and let's do the next one. Y equals 3 sine of pi over 2. Now, pi over 2, that's the number 1. So that means y is equal to 3 times 1, or 3. And y equals 3, let's neaten that a little bit. 3 sine of pi, and the sign out at pi is 0, so it's going to be 0 again. Y equals 3 sine 3 pi over 2. Well, 3 pi over 2, the sign's -1, so we get a -3 here. And then at 2 pi, it's the same as 0, so we have 0. Now let's graph these. We have 0, 0, pi over 2 and 3, pi and 0, 3 pi over 2 and -3, and then here. So we have a bigger curve. I want to get this a little more real. I'm not so good at doing them, but I think, let's see if the third time here makes it a little bit better. Well, it just missed, so I'm gonna make that a little bigger circle. So you can tell I'm supposed to be getting to that. So an approximation is okay here on doing it by hand, but it needs to just be a pretty close approximation and a serious attempt. I want it to come down from there and not go up more. Okay, and then I'm going to try to curve it. Okay, a serious attempt at curves will be good here. And we've done one period up to 2 pi and a second period to 4 pi. So graphing y equals cosine x first needs finding these 4 things again. And we can see the amplitude is 1. So absolute value of A, or absolute value of y is just 1. There's nothing afterwards, so the vertical shift is just 0. And for x, that's in the bx minus c form. So that means we have it set like this, where the b is 1 and the c is 0. So for the period, 2 pi over 1 or over b, well, that means it's over 1, so it's just 2 pi. And identify the phase shift, and the phase shift would be c over b. C is 0, and b is 1, so that means it's a 0. Not a 0 over 1, you have to reduce, so make sure you keep it 0 if this is true for any ones you do. Let's use the chart. Now, notice there's nothing on these, and with that means we're going to take a period and split that in 4. Well, that means right now it's the same as the last ones that we've done. So let's take that 2 pi, and half of that's pi, half of that's pi over 2. So if we go pi over 2, and then pi over 2, now we have our 4. And down here, those are the x values. So I'm going to set them correctly in the coordinate points for using them. Now we have y equals cosine x. So let's go ahead and calculate these. So for x now, we'll put 0. And the cosine of 0, we need the unit circle and see that at 0 degrees, the x value is 1 and the y value is 0. And we're looking for the cosine, and the cosine is the x value. So y equals, this is 1. So put a 1 down here. And then we'll do the same for pi over 2. Y equals the cosine of pi over 2. That's up here. where the x is 0 and the y is 1, but we're looking for the x value for cosine, so y equals 0. And then y equals the cosine of pi. And over here, I want parentheses, we have -1 and 0. And for 3 pi over 2, we're back to 0 for the x value, and that's the only one we're looking for. We're not looking for the sine, which is -1. We're looking for the cosine of 3 pi over 2, which is equal to 0. There, just to complete this. Clean it up a bit here. Well, I don't quite know what happened, but I think we're in pretty good shape here to still continue this. So, pi over 2, we're going to do the same thing. Y equals the cosine of 2 pi. All right, and at 2 pi, that means we're back to 1 for that. And now let's graph these. 0 and 1. Do that in blue. At pi over 2, it's at 0. At pi, we're at -1, then we're back to 0, and then we're back to 1. And so that is our curve here. And then we're going to continue it just like the other one, so we get a second period in here. Now, one interesting thing to know about this, to make that a little clearer, that's starting to go down now, is that if we were to go back on here, you can see now that this is actually the sine curve just started from an earlier different point. So the cosine and sine curve are actually the same, they're just in different places. They're just moved away from each other. Okay. Now we're going to graph cosine x again, but this time with a -2, which means we have a vertical shift here. So we have a vertical shift of -2. There's only a 1 there in front of it, so the amplitude is a 1 because the absolute value of a, or the absolute value of 1 is 1. And here again, it's just x. So bx minus c, and b is 1, because that's 1x minus 0. So c is equal to 0. So 2 pi over 1, and so it's 2 pi. And c over b, or 0 over 1, which is 0. And this is what's important here at 2 pi, or most importantly, I should say, for 2 pi, we'll split that as normal. And then we're going to do this cosine x minus 2. So y equals cosine of x minus 2. So y equals the cosine of 0 minus 2. So the cosine at 0 is a 1. So we have 1 minus 2, or a -1. So that means when we're at 0, we're at -1 now. Let's write the rest of these in already, so it'll be easier as we do each thing. So for the second one, it's y equals cosine of pi over 2 minus 2. The cosine at pi over 2, or 90 degrees, is 0, so y equals -2. Y equals the cosine of pi minus 2. The cosine at pi is a -1 minus 2, so y is equal to a -3. Okay. So then we have y equals the cosine of 3 pi over 2 minus 2. At 3 pi over 2, the cosine is 0, so we're at -2 here. Y equals the cosine of 2 pi minus 2, and 2 pi is a +1, so y equals 1 minus 2, which is a -1. Now let's graph these. 0 and -1, pi over 2 and -2. Okay, pi goes all the way down to -3. And then we're back to here and here. So that's supposed to be a curved thing. So that means we need to curve it like this. And then to repeat here, that's the second one. And then down to here, and here, and here. So what this really is, if I come back to these, watch what happens when I graph the parent function. All we really did with this was that everything went down 2. Every single point went down 2. That's what this -2 does. It moved everything down 2. Right? Just like other graphs do, but in this case, you can see it with this one here. All right, let's take a look now at one that has all of these things. Okay? So we have an amplitude, absolute value 2. We have a vertical shift of -1. And we have a b of 3 and a c of pi. So for the period, we do 2 pi over b, which is a 3. 2 pi over 3. Mind us here. And then the phase shift is c over b, which is pi over, and b was 3. So the phase shift is pi over 3. Okay, so that's how much it would move from its original main spot. This is what I want to look at focusing on, 2 pi over 3. I'm going to come down to the bottom, and you'll see now I've set this up to walk us through getting the points we need, and 2 pi over 3 was at the end. So what I did is I took 2 pi over 3 and had to put points in between to see where the curves would go. And I already set some of this up. You see, I chose these, and here's the reason I did. Look at the unit circle. 2 pi over 3 is essentially 120 degrees. So if I take that and split that into 4s, I get these places. This one is 30 degrees, this one's 60 degrees, and this one's 90 degrees. Or in terms of radians, we have pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2. And that's why I put pi over 6 here to match the 30 degrees, pi over 3 to match the 60 degrees, which is the middle one. So like that's exactly halfway in the first period of this. And then pi over 2, which is 90 degrees. And then I started now figuring these out. So our function is y equals 2 sine 3x plus pi minus 1. So 0. So I have 2 sine 3 times x. So this is the x, and I'm choosing 0 for my first one plus pi. So 3 times 0, well, here's the thing, is 0 times 3 is 0. So we have 0 plus pi. I think I'll continue in blue. It makes a little more contrast. That's 0 plus pi, which is pi. And the sine at pi, right, we use the unit circle again. And at pi, the sine is 0. So like here, back on this thing, here we have 0, 1 and 0. And I start reversing them again, 1 and 0. At pi over 2, and that's where we have to remember now for pi over 6. And I guess what I can do is remind us that well, actually, first let's change it because I can't do that with pi over 6. So right now we see we have 0 minus 1. That's how we get minus 1 here. That's how we get that. Now, on the next one, pi over 6 goes in place of x. 3 pi over 6, the 3 goes into the 6 twice, so that's actually pi over 2 plus pi. Now, here's where it gets a little more work. Pi over 2 plus pi, I can't really add those so easily unless I change pi to 2 pi over 2, because I have to have the same denominators in order to add those. So now that I have the same denominators, I can add them, and I get 3 pi over 2. And at 3 pi over 2, the x-axis there, or rather, yeah, at this point it's -1, the x value is -1, so I put -1 in here. 2 times -1 is -2 minus 1, and that gives us -3. And that's why we get this one. Now let's look over at the next one. 3 goes in place of x. The 3's cancel, and I get pi. And 2 pi is back over here. Okay, so with 2 pi, that means the sine of that is 0. And that's 0 minus 1, so we get -1 again. Well, we've gotten -1 and -3 and -1. On this next one, we get 3 pi over 2. Well, I need to write this again as 2 pi over 2, which gives us 5 pi over 2. And that's the same, as pi over 2. So we get a 1 here. And that gives us 2 minus 1, or the 1. And then when we cancel this one out, we put 2 pi over 3 in here. 2 pi plus pi, that's 3 pi, which is the same as 1 pi, which means it's 0 here, and we get -1. So the key to these is to put in the angle and then multiply it and see what comes up. We end up with pi, which is easy to work with anyway. So I did that here. 3 over 6 is 2. But then I had to change this one to make it 2 pi over 2 in order to get the same denominator so I could add the numerators. And I did that for each one of them. Now let's graph those points. Okay. So 0 and -1. Pi over 2 and -3. Pi and -1. 3 pi over 2 and 1, so I'm up here. And 2 pi, let's see, wait a minute, 3 pi, wait a minute, hold on a second, I've got a problem. I started graphing these with the new numbers that were in there. So if you were doing this and following along, please stop and wait, because I forgot when I did this, and I saw that the period was 2 pi over 3, and I did this, is that I needed to mark those. So let's right now look at the fact that these are my x values, so I need to put them here on this line. I already have pi over 2 and 0. And 2 pi over 3, the other ones are not, though. And that's because 2 pi over 3, about 120 degrees, so let's use this here. I'm going to use this one, but I need to go to where 2 pi over 3 is. Okay? And that means that's going to be just about here. So 2 pi over 3. And then I need to take the first 90 degrees and split it into about where 30 and 60 would be for pi over 6 and pi over 3. And that's because this is my first period. So the period is not going out to pi over 2. It's crunched in a great deal. Now, let me erase those so we can now graph those points. All right. So you saw that I forgot to do that at first, and thankfully I figured out pretty quickly. You'll have to make sure when you graph these that you remember that that's crunched in like that. So for 0, we still go to 0 and -1. For pi over 6, we're going to -3. For pi over 3, we're going to -1. For pi over 2, we're going to +1. And then for 2 pi over 3, we're back to a negative 1. Okay, so that means I am going to graph this and try to do it so it's got a curve there, and it comes up here, and it curves, and that is one period of it. Normally, in fact, let's see, this one's a sine curve. So a sine curve would normally go here. So what's happened, oh, hold on. Okay. What has happened here is that this sine curve got crunched in and pulled apart, or pulled up and down. So it's like a rubber band being pulled up and down, and that brings it in as well. Now we need to do 2 of them, so this one and this one are like the same, so I need to find this one, which would be, oh, now I'm going to need to find my next 30 degrees. So I need to go 30, 30, another 30, and another 30, which means for this one, I would be at, I would essentially double 2 pi over 3, so it's going to be 4 pi over 3. Or 240 degrees, but I can do approximate points of the others. Okay. And then continue the curves for them. Oops, it's not there, it's down here. So let's curve that better now. Okay, so now I have two of these. This is the first one, and then this is the second period of it. Oh, that is one of the most complicated ones you'll face when things change, when all 4 of the things change, and you especially change the period. And so you use the period, so you're not using the like just pi over 4, pi over 2, 45, 90, 135, 180. This one was crunched in a little bit more than that. So it's an interesting kind of problem. And you get a chance to see how to do all 4 of those. Now here's a good one that does the same kind of thing. I recommend you take a moment and practice it. Okay, go ahead and do this one yourself, and then come back and pause the video, and I'll come back and you'll see me start doing it. It's in about 3 seconds of my time. Well, welcome back. It was about 3 seconds my time. Now let's go ahead and take a look at how to do this. So we're going to use the same kinds of things we did before in that. A, so it's absolute value of 1/2, so just 1/2. Haven't had a negative there yet, but if we did, we would do the absolute value. Here is B, and here is C, and we have a positive 1 for the vertical shift, so that's easy. B is 2. For the period, we need 2 pi over B. The 2's cancel, so the period's pi. And the phase shift will be C over B, which makes it negative pi. Oops, no, it's not negative. It's only if that was positive, they would make it negative. So means we're doing C over B, and C is pi and B. So the phase shift, oh, yeah, I should keep forgetting that that's 2. So C over B, that's pi over 2. So it means it moves from its original spot by essentially half the unit circle kind of thing. So here is the period. Let's come down here and put that, and half of that, and half of that, and 3/4 of it. And now we will start putting these things in. And let's do that. I'll do that with black here. So y equals 1/2 the cosine of 2 times 0. Oops, don't need that parentheses yet. Minus pi plus 1. If I extend this, that'll be easier to see on there. So y equals 1/2. Well, that's 0 minus pi, okay. Cosine of negative pi plus 1. So negative pi, we're going to go, if we're on a unit circle, okay, so we go around to here, here's pi, here's 2 pi, but if we're at 0 or at 2 pi and we go back, which is what negative pi is, we'll be at pi. So negative pi is the same as pi. And that's where we also need for each of these spots now. For at pi here, negative 1 and 0. Here is 1 and 0. So let's just do our main ones. 0, 1, 0, and negative 1. Back to here, that's y equals 1/2. The cosine is negative 1 plus 1. Y is equal to negative 1/2 plus 1. Well, 1 take away 1, negative 1/2 is 1/2. Or we can do it as a decimal of 0.5. So this is saying we have an x of 0. So when the degree is 0, we're at 0.5 or 1/2. So I'll do, doesn't matter which one, I'll do 0.5 this time. Okay. Or actually, what I want to do is write that so it's not misleading as if I was, so it's like either of these would be okay. Yeah, that won't be misleading unless I don't write my 5 right there. Now let's do this with pi over 4. So y equals 1/2 the cosine of 2 times pi over 4 minus pi plus 1. Y equals 1/2 the cosine, 2 goes into 4 twice, so we have pi over 2 minus pi plus 1. We cannot add or subtract them unless the fractions are the same. So that means I need to make this 2 pi over 2 in order to subtract those. 1/2 cosine. So that's 1 minus 2 is a negative 1, so we get negative pi over 2 plus 1. Well, on the unit circle, if you go back up a half pi, or a pi over 2, yeah, you get to 3 pi over 2 plus 1. Because over here, if we're at 2 pi and going back here, that's negative pi over 2. Or, yep, negative pi over 2 gets you to 3 pi over 2. So going from 4 pi over 2, take away 1 pi over 2 gets you to 3 pi over 2. Now that doesn't look. There. So 3 pi over 2, that's better to see. Well, and at that point, the cosine is 0. So let's come back here. Y equals 1/2. This is 0 plus 1. So that means, since all that's 0, that means y is equal to 1. And here I was at pi over 4. And before I forget, let's go ahead and I'm going to put all of these in here now. Oh, I put 3 pi over 4. Yep, no, that was right. I'm trying to think of what I'm off on, and I'm not off on anything. Now let's do the next one. Y equals 1/2 cosine of 2 times pi over 2 minus pi plus 1. Y equals 1/2 cosine. Well, the 2's cancel, so we get pi minus pi. Well, we're not going to have to worry about fractions on this one. 1/2, well, that's cosine of 0. Pi minus pi is 0. And at 0, the cosine is 1. So y equals 1/2 of 1 plus 1. Y equals 0.5 or 1/2 plus 1. So 1.5 or 1.5. I'm going to put 1.5. Do the same thing here on this one. 1/2 cosine 2, 3 pi over 4 minus pi plus 1. Well, this little thing in here, 2 goes into 4 twice, we get 3 pi over 2 minus pi, right? And we can't do it unless it's a fraction. 2 now. 3 of them, take away 2 of them is just 1, so it's pi over 2. And now let's do the rest of this. So that's the cosine of pi over 2, and it's 1/2 the cosine of pi over 2. Y equals 1/2 the cosine of all of this, pi over 2, and then plus 1. Well, pi over 2, the cosine at pi over 2 is up here, and that's a 0. So y equals 1/2 0 plus 1, and that's 0, so it's just y is 1. And the last one, the good thing here is because it rotates, we know the last one will be the same, but I'll do it anyway here. Pi equals 1/2 cosine of 2 times pi. So I'm putting pi in here, minus pi plus 1. Cosine 2 pi minus pi plus 1. That means just pi. So y is 1/2 cosine of pi plus 1. The cosine at pi is a -1. So we get -1/2 plus 1, which is a 0.5, which is the same as over on the first one. And now let's graph these up here. Let's graph these now up here, 0 and 0.5. And next is it's pi over 4, which is at here. And so we're actually going just to that. So at pi over 4, we've gone up to 1. At pi over 2, we've gone to 1.5. So we go up a little higher. At 3 pi over 2, we're back down to 1. And then at pi, we're at 1/2. So the curve of this has sort of a mountain to it there. I think I went a little higher on that 1/2 one than I should have. So I think that's more like about here. I'll make a slightly gentler curve. Oh, that wasn't a very good line. Okay, I think that's as good as I'm going to get here for this. So let's do the next quarters. All right, so since these two are the same, I'll go up to here and up to here and then down to the sink. Okay, so I think I'm going to be satisfied with that one. So I have one cycle here and then another cycle here. And then it would continue either direction if I wanted to. So that's the graph of this one. Whoops, need to include the whole thing. And that graph looks like this. And we were able to get the points by doing all of this work, putting in the angle amount into this equation, into the x for the equation. And you can calculate all of them using just the unit circle. Another video will show how to do all this on a graphing calculator, which is a great backup, but doing it by hand is still pretty useful to understand the details of how these need to be graphed. Thank you for watching. I hope this was helpful. And remember to put your graphing calculator on radians and move it out of radians when you're done graphing it. And you should do it to check these when you're doing them. Okay, thank you for watching.